Hey guys, so we're going to continue on factoring. This time we're going to focus on a very special case of factoring, which is known as difference of two squares. Okay, so to start us off, I actually want to start us with multiplying rather than factoring first, just to see if we can notice some of the patterns. Okay, so here I have a couple of multiplying binomials questions. So I want you to multiply these out and then come back and check your answer. And then we will talk about what do we notice. Okay, so multiply and then come check your answer. Okay, so for this one, you should have gotten x squared minus 25. This one, you should have gotten 16x squared minus 1. And this one here, you should have gotten 9 minus 4x squared. Okay, so here, I want you to pause here and type in what patterns do you notice, right? So what patterns do you notice going from here to here, here to here, here to here, or your answers? What are some things you notice? Okay, so pause here, answer the question. Okay, so here are some things I noticed you can add to your list. Okay, so one thing I noticed is that the middle term is not there. And what I mean is that there is no bx term, right? So when we're multiplying our polynomials or trinomials, right, when we do our diamond or whatever, we have a b term, right? There is no bx, right? The x terms ends up canceling each other out, right? Negative 5x, 5x, negative 4x, 4x, negative 6x, 6x. They canceled each other out, okay? Another thing I noticed is that both the first and the last term are perfect squares, right? X squared is a perfect square, 25 is a perfect square, 16x squared is a perfect square, 1 is a perfect square, 9 is a perfect square, 4x squared is a perfect square, okay? And then another thing I noticed is that that last term is always negative, right? Minus 25, minus 1, minus 4x squared, okay? So what it is that these binomial pairs above, they are known as conjugate pairs, right? And what we should notice is that the terms are the same number, right? It's x and 5, x and 5, 4x and 1, 4x and 1, 3 and 2x, 3 and 2x, right? We notice that the signs of the first term are the same, right? Or in this case, they're both positive. Right? Note, positive x, 4x, 4x, 3, 3. They're the same. Okay. Signs of the second terms are opposite, right? They ended up being opposite signs. Right? So here, positive 5, negative 5. Positive 1, negative 1. Positive 2x, negative 2x. They were opposite signs. Okay? We will use this pattern that we noticed to create a factoring shortcut known as a difference of two squares. Okay? A difference of two squares follow this pattern, right? So when we have, it's just two terms, a squared minus b squared, we can easily factor it into a plus b, a minus b. Okay? So what is the criteria for difference of two squares? First, we need two terms. Okay, so something like x squared minus 25, right? Two terms. X squared is a term, negative 25 is another term. Okay. Another thing, both the first and last term need to be perfect squares, right? X squared is clearly a perfect square, x to the second power. 25 is a perfect square as well, it is 5 squared. Okay. And then the third thing is it has to be a difference. It has to be a subtraction sign in between both of them. And then all we need to do, x5, right? So x plus 5, x minus 5. Right. So here, we're going to factor using the following thing. Okay. So here, it reminds us again, as with any factoring of the problem, the first step is to check for a GCF, greatest common factor. Okay. So let's start here. X squared minus 81. Okay. There's nothing they have in common. There's no common factor. Okay. This is a difference of two squares, right? So first, it's two terms. X squared is a term, negative 81 is a term. The first and last term are both perfect squares. X squared is a perfect square, and 81 is a perfect square. It's 9 squared, and there's a difference in between. Okay? So to factor, x Square root of 81 is 9, so it's going to be x plus 9, x minus 9. Nice and easy. Okay. If we don't believe it, right, we can always distribute to check, right? So x times x gives me x squared. X times negative 9 is negative 9x. 9x. Negative 9 times 9, negative 81. These cancel out, leaving me with x squared minus 81. Does it match the original? Yes, it does. So that means I did it correctly. Okay. Let's do the next one here. 2x squared minus 200. Okay. Both 2 and 200, GCF is 2. So I'm going to pull that out. Okay. Then I noticed I have two terms. X squared and 100 are both perfect squares. It's a difference in between. So it follows this pattern. I can just do, right, square root of 100 is 10, so it's going to be x plus 10, x minus 10. And then don't forget the 2 that you pulled out needs to still be in front. Okay, so that way it equals back to your original. Right? Same thing here. So 9x cubed minus 4x, I'm going to start by pulling out a common factor. Okay, they both have an x in common, so I'm going to pull that out. Then I'm left with 9x squared and a negative 4. Okay. Oh, two terms, check. First and last term are perfect squares. Yep, 9x squared is a perfect square. 4 is a perfect square, so that works. Difference, yep, it is a subtraction sign in between, so all I have to do, okay, if I square root this, square root of 9 is 3. Square root of x squared gets rid of the square. Square root of 4 is 2, so 3x minus 2 and 3x plus 2. Okay. There you go. Okay. The next one here, 49 minus 25x squared. Okay, I notice two terms. First and last term are perfect squares, 49, 25x squared, yep. Difference, yep, there is a subtraction sign in between. Okay, no GCF to pull out, so square root of 49 is 7, so I'm going to have 7 and 7. Okay, square root of 25 is 5, so I'm going to have a plus 5 and a minus 5. And then x squared, square root that, get rid of the square, it's x and x. So 7 plus 5x and 7 minus 5x. Okay. I'm going to have you do this next one on your own. Okay, so 9 minus 64, x squared. Okay, so do it on your own. Come back, check your answer. Okay, so you should have gotten 3 plus 8x and 3 minus 8x. Right, so again, it works, right? It's two terms. First and last term are perfect squares. It's a subtraction in the middle. Okay, so the first term here in my binomial, square root of 9 is 3, so that's why it's a 3 and a 3. Square root of 64 is 8, and then square root of x squared is x. So 3 plus 8x, 3 minus 8x. Okay, try this one, and then come back and check your work. Okay, so here you should have gotten 2x plus 9, 2x minus 9, right? Square root of 4 is 2. Square root of x squared is x, so that's why it's 2x, 2x. And then for the 81, square root of 81 is 9, so that's why it's plus 9 and minus 9. Okay. So you might be like, Miss Ng, what if I can't remember it? That's absolutely fine. If you can't remember this, you can still use what we know about the diamond method or the box method as well. Okay, so I'm going to rewrite this as a trinomial. Okay, and then one thing we notice is there was no bx. Okay, and the reason why is because b is 0, and that's why it's no longer there, right? Because there's no point in writing 4x squared plus 0x minus 1. So that's why we don't normally write it, and that's why it becomes 4x squared minus 1. Right? But if you can recognize that this and this is the same, and you can rewrite it as a trinomial, even if you don't remember the whole trick with difference of two squares, you can still use what we know, right? So in this case, a would be 4, b is 0, that's why it's not there, and then c here is negative 1. Okay, with our normal x method, a times c, so 4 times negative 1 is negative 4, b is 0. Okay, so you're asking yourself, what times what gives you negative 4, but when you add it gives you 0? Okay, well the answer is 2 and negative 2, right? 2 times negative 2 is negative 4, but when you add them, they cancel each other out, leaving you with 0. Okay? Then you can do what we know about grouping and stuff, so 2x minus 2x minus 1. Right? And we saw this when we were doing that multiplication thing, that the reason why it canceled out. Okay? Okay, then factor by grouping split. This one has a 2x. I'm left with 2x plus 1. Okay, this one, factor out a negative 1. I'm left with 2x plus 1. And so I have 2x plus 1, 2x minus 1. Which you notice if you did the whole difference of two squares thing, right? Square root of 4x squared is 2x, 2x. Square root of 1, negative 1 here, right? So if you forget this whole pattern thing, you can still do the x method. That is fine. Just recognize for difference of two squares, our b here is 0. That's why there isn't some x to the power of 1. Okay? That's it for today. Have a great rest of the day. Bye, guys.